Hi everyone, in this video we are going to go over all of the mathematics that you need for physics. So if you were to go to college today, these would be the math subjects that you would study in order to get a physics degree. And we're going to go through everything step by step, starting in order, starting from the most basic of mathematics. So if you barely know any math, that's okay. We're going to start from the beginning. Also, I want to say that if you're a physics student now and you're struggling with math, it's okay. Just know that in time, you do get better. It takes a lot of work to get good at physics, and it takes a lot of work to get good at math. Don't give up. Keep trying. All right, let's go ahead and get started right away. I've also included some extra subjects that are a little bit more advanced. So if you're a physics major, these could be good electives. So let's start from the beginning. I'm going to just go ahead and start from the very, very basic. So if you knew basically very, very little math and you were just starting out, maybe you haven't been in school for a long time, you would start with a very, very basic book. And I picked this one because this one is written by a good author, Blitzer. He also has a college algebra book, which I've used to teach in college, which I think is great. But this book is for beginners. You basically spend a lot of time doing stuff like this. So a lot of algebraic manipulation, adding, subtracting, dividing rational expressions, a lot of stuff with like square roots. So with books like this, in fact, most of these books, what you can do is you basically sit down and you work through them, and you can check your answer in the back of the book to the odd numbered exercises. So that's the best way to use these. By the way, all of these books are textbooks, okay? They are not like workbooks or anything like that. So a textbook is a book that is used in college, and it contains a significant amount of information. As opposed to like workbooks. On Amazon, you see a lot of workbooks that are like self-published by people. Those are really good too, but those don't have the depth or the breadth that an actual textbook has. I'm sorry, I have to smell this book. Oh, it smells amazing. This copy smells so good. This is a wonderful book. By the way, I'll leave links in the description to all of these books in case you want to check any of these out. They're all excellent books. As a collector of math books, I have thousands. I've been collecting for years. So yeah, wonderful book. I highly recommend it. So once you know some algebra, or if you feel like you know a little bit of algebra already, you can just skip this and jump into a little bit more advanced mathematics, something like college algebra. So this is actually a book that I have used to teach college algebra in actual college, and I think it's a wonderful book. It is well written. It has answers in the back to the odd numbered exercises. So the difference between this one and the one I showed you before, this one's gonna have more advanced stuff. It's gonna have functions, okay? A lot of stuff with functions. It's gonna have stuff with polynomials. So it's not just about algebraic manipulation. It's a little bit deeper. It's not just like, here, simplify this, perform the operations. No, it's like, here, use this theorem, perform this synthetic division and deduce a result. So it's a little bit more involved. I highly recommend that if you don't have an algebra book, that you at least get this one. After you take college algebra, so you do intermediate algebra if you need to, unless you test out, college algebra, okay, most people start here, and then after you pass your college algebra class and you get an A, because I know you will, you have to take two more classes, pre-calculus and trigonometry. Those classes are typically taught using the same book. The books usually go by names such as pre-calculus or algebra and trigonometry. This is a graphical approach to algebra and trigonometry. This is the one by Hornsby, Lyle, and Roxwold. This is the teacher's edition. This is the one I've used to teach pre-calculus, trigonometry, as well as a combo course in college. Great book. It's got a lot of good examples. It basically covers all the material that the Blitzer book covers, but it's harder. Okay, the examples are harder. The exercises are harder. And it has extra stuff. It's got induction, it's got matrices, it talks about conic sections, which are parabolas, ellipses, circles, and hyperbolas. It's got all kinds of stuff, sequences and series. I gotta smell it, I'm sorry. So this is nice because with one book, you can take two courses, right? Pre-calc and trig. This is core, okay? So this is like the requirement for the next subject that you need to learn when you study physics, and you need to learn it well. It's calculus. I've got a book here, I'm gonna dig it out. So calculus is extremely important. This is Calculus by James Stewart. I picked this one because, well, this is the most famous calculus book in the world because it's the most popular. It was written by a Canadian mathematician. His name was James Stewart. and he passed away several years ago. And this is a great book. I used the early Transcendentals version of this book when I was a student. It doesn't really matter which one you use. Great book. If you don't have a big, thick calculus book, you need one, right? Every engineer needs a big, thick. It doesn't have to be this one, but just make sure you get a big, thick calculus book. I have several big, thick calculus books. And again, I picked this one because it's so popular. Now, again, this is used for Calculus 1, Calculus 2, and Calculus 3. So all engineers always have to take Calc 1, Calc 2, Calc 3. Some schools will require that engineers have like a Calc 4 class, and that's going to focus on the latter chapters of this book, like chapter 17. Yeah, mainly chapter 17. A Calc 4 course would focus on stuff like that. So solid book for learning. I highly recommend, again, that every physics student get a calculus book. It is absolutely critical to have one of these. All right, so after you know the basics, you know your algebra, you know your calculus, this is where you can jump into some other stuff. So typically most physics students will take a course on differential equations. This is Differential Equations and Boundary Value Problems by Nagel, Saf, and Snyder. And so this one's good because it has actual partial differential equations in it as well. So there's other versions. There's the version without the boundary value problems, which is also fine. But this version has some extra stuff in it that could be helpful for physics students. And this is the book that I used when I was in college. When I've taught differential equations, I've used a different book, but I purposely picked this book for the video because this has partial differential equations in it, and I think that can help you if you're an engineering student. So nice book. I've read big portions of it. I've done a lot of the exercises. I've taken exercises from here and put them on tests for my class. So it's a solid book. It's a little bit harder than some of the other DE books, but it's very, very good. It's got good examples. So that's basically the core, calculus 1, 2, 3, differential equations. Oh, here's another differential equations book. Let me show you. So this is the one I've used to teach. Here's another option. And this one's also good. Notice how much thinner it is compared to the Saf and Snyder book, right? Look at the difference in thickness, right? So yeah, this one's also really good. Again, this is the one I've used to teach, so obviously I like it. But yeah, you have some choices. Most physics students have to take a basic stats course, but I wanted to include a more advanced stat course for you because why not? If you're going to do physics, you should take some more advanced stuff. So here's a probability and statistics book for engineers and scientists. This one basically uses calculus for a lot of the examples. So this could be appropriate and could be very helpful if you're going into physics. Whereas this one is probably used for a course that you're required to take. This is a basic stats book. So this is used for like the courses that everyone takes. Like a business major would take a stats course with a book like this. So easy stats. I've taught this course in college for years, and I've actually used this book in the past to teach the course. And I do think that this is a great book and it's got great explanations. So I actually recommend getting both. Something like this because this is more readable and easier to understand. Hence the name, Understandable Statistics. This one's more hardcore and it's got calculus. A lot of people don't like statistics, but I really recommend that you learn it and appreciate it and try. I mean, maybe you'll like it. These books are probably really inexpensive. I don't think they're that popular. All right, so then we have another subject which is also very popular. It's called linear algebra. And I purposely picked this book because this is a thicker book. So all physics majors will usually be required to take some linear algebra. If you're not required, I definitely recommend you take it as an elective. I picked this book because it's so thick and it's got so much content, and it's also really good for beginners. I don't think I've talked about this book too much, but it's a great book for self-study. It's called Linear Algebra, Theory and Applications, and it's by Shanae and Kincaid. Let me give it a whiff here. So linear algebra, you study matrices, determinants, linear maps, systems of equations, etc. So some of the stuff you will already have seen in your differential equations course, because in differential equations, you do some linear algebra prior to studying higher order differential equations that are linear with constant coefficients. So, wonderful book, and it will help you learn linear algebra. Moving on, another good possible elective for you if you decide to study physics would be partial differential equations. So partial differential equations is a course that you would take after differential equations. This is actually the book I used when I was in college and I took partial differential equations. I think it's an okay book, and that's my honest opinion of most partial differential equations books, because partial differential equations is hard. Like, the problems are hard, the techniques are tough. It takes a lot of time and energy. But I definitely recommend you take a course on it if you have the opportunity to. I was fortunate to have an amazing teacher. I'm gonna smell it. It smells amazing. I like this book. There are some typos in the solutions. I found one or two which are painful, but you can find the errata, I believe I said that correctly, online. Just Google it. But I have found some typos back here. There was one that caused me like 3 hours of pain once. So you do have some answers in the back. This is hard. This is hard stuff. It brings back some memories. So I personally have only taken one course on partial differential equations. I haven't taken like a graduate course on it or anything. But I took an undergrad course. I got an A. It was a fun experience. And I definitely think it'd be great if you're a physics major to take some PDEs, right? Really, really important. And then we have complex analysis, or complex variables. This is another class that you can take as a physics student, as an elective. When I took this class, most of the class was physics students and engineering students. This is the book that I used for the course, and I highly recommend this book. There's other books you can use, but I like this one because it does have, this one does have, if we look in the back, you do get some answers, right? Whereas like other popular books, like at least the newer edition of Brown and Churchill, the one I have, the one I looked at recently, it doesn't have answers in the back. So this one has answers in the back of the book. And I've done a lot of the exercises from this book. I use this for a course, right? So this is basically like calculus, except you have complex numbers. So you have some new theory that's created, and you have a lot of the old theory that's repeated. Like all the stuff for limits and stuff is very, very similar. Same thing with derivatives. All the integration rules are still there. They still apply. All the series stuff is similar, like the power series convergence theorem in calculus is the same pretty much in complex variables. In fact, when I teach calculus 2, I usually show students both of those, the real case and the complex case. But beautiful subject. Highly recommend that you take this as an elective if it's not required for your physics degree, right? And last but certainly not least, I wanted to include a general book. I have some books on mathematical physics, or like, math for physics, but this is very similar. This is Advanced Engineering Mathematics by Erwin Kreisig. This book is awesome. Okay, this book is awesome. The worst thing about this book is that you can never find it cheap. Let me show you why this book is awesome. Look at the contents of this book. Let me just show you. This is pretty cool. It has I think it has everything we've gone over. It has all the topics. Check this out. So it starts with like a basic review of calculus and some determinant stuff and just really basic mathematics. And then differential equations. It basically teaches you differential equations. This is where a differential equations course starts, by the way. So like if you go to college and you take DE, like this is where it starts. Like when I teach DE, this is where I start, right? This is like, it's ridiculous. And it's not even a DE book. And then here we go, more differential equations, series solutions of differential equations, and then this Laplace transform stuff here, it's also differential equations, right? So all of this is differential equations. So instead of getting one of these books, in theory, you could use this. Now, I don't recommend that. I recommend getting all the books, but you could. Calc 3. This is really important, so it gives you extra content on Calc 3. Okay, that's really, really key, especially for physics. More Calc 3, more linear algebra. So you've got linear algebra, Fourier series and integrals, okay, partial differential equations. This is stuff you'll see in PDEs, both of these things typically. Definitely this. More stuff with complex variables. More stuff with complex variables. More stuff with complex variables. Then you've got some Calc 2 stuff here. This is sequences and series. More Calc 2 stuff, although this is Laurent series. This is complex numbers. More complex number stuff. More complex number stuff. Some applied math stuff. Probability and statistics. Wow, so you've got Calculus 1, Calculus 2, Calculus 3. You don't have all of Calculus 1, you've just got some of it, right? But basically, you've got a lot of Calc 3 in here, the multivariable calc, which is what you really need for physics, right? Then you've got linear algebra, you've got complex variables, you've got stats. I mean, it has everything. This book also has some answers in the back of the book. It doesn't have all the answers, but you can see that it does have some, right? So you do get some answers, which is quite nice. Oh, what's this? Look, separation of variables. We have seen that the vibrations of an elastic string are governed by the one-dimensional wave equation, where u of xt is the deflection of the string. Since the string is fixed at the ends, x equals 0 and x equals L, we have two boundary conditions. Yep, you have a boundary value problem. Very cool. This is really cool. So this stuff is gold. This book is incredible. I got to smell it. It's calling me. Ah, it smells amazing. It smells amazing. But yeah, the biggest downside of this book is the price. Like, you can never find it inexpensively. It's always expensive. And I think because it's always in demand, right? I mean, if you're an engineering student, you want this book. If you're a physics student, you want this book. If you're a math student, you want this book, right? Because it's good. There's other books like this, but this is probably, like, this is my favorite one. I think this is a legendary book. So what do? So you want to learn physics, you want to learn math or physics, and you go out and you buy some books, and I'll leave some links in the description. So how do you proceed? So my advice is the following. If you're trying to learn this stuff, you know, there's all kinds of advice I can give you, and I can talk about it forever, but let me just say, first thing is first, you want to create time in your day, so you can do that by getting up early. So for example, let's say that you normally get up at 7 a.m., right? And you want to learn a little bit of math because you want to study physics. You feel like your math is weak. So my advice would be get up like, I don't know, an hour early. Get up at 6 a.m. and then just start your day, right? You wake up at 6, do whatever it is you do in the morning to get ready, and have your coffee, go to the bathroom, brush your teeth, whatever, and then get to work, kind of like psych yourself up. So get up an hour early and commit to at least 20, 30 minutes of mathematics. And that's going to make a huge difference, especially when you do it every day. Like, the first time it'll be really hard, maybe the first few times. But after you do it for a full week, like if you can go a full week of this like morning routine where you study, you're going to feel super empowered, and you're going to feel like you can do anything in this world, right? Especially when you build that discipline by taking action and actually doing math every day. And you'll become a monster. You'll become really, really good. The big thing for physics, by the way, is so when you take physics, there's a lot of reading. There's, you know what physics is, right? So there's a lot of reading. It's basically an entire course of word problems. And for many people, that's like their worst nightmare. So my advice with physics is take your time, read the book, make sure you understand the math. When I took physics, my math was not very good, right? And it caused me a lot of pain. So yeah, this can help you. This can help you. If you want to learn math, by the way, I do have courses. They're on my website, or they're on Udemy. But if you get them, use the links from my website, mathsorcerer.com. When you use those links, it helps me greatly, and I've lowered the prices. You can also get the links for my courses through the description of any of my videos. And I've got courses on most of these topics, calculus, differential equations. I've got some algebra, I have some trig, etc. So yeah, advanced calculus, abstract algebra, but those aren't things you'll need for physics, right? Those are really for math majors, right? So yeah. But yeah, I just thought I would randomly make this video really quickly. Some people left a comment about it. They're like, oh, you should make a video for physics. And so I thought, all right, let me see what books I have that are really good for physics. And I think these are a good choice. The only thing I don't have here, which I couldn't find, and I have it, is another book on vector calculus. Like, for example, the book by Coley, Susan Coley, on vector calculus is really good. Now, the book by Coley is not going to have, it's just basically going to have all of the stuff you see at the end of this book, okay? Because it's an entire book on vector calculus. So it would be used for like a vector calculus course or a Calc 4 course, which is not even offered at many schools. But it's still a good book if you're going to do physics. So I still recommend the book by Coley, and I don't know where it is. I don't know if it's on these bookshelves or maybe it's over here on the floor. I don't really know where it is. And there's another room full of books where I have like several hundred books. So it's in one of those rooms. In any case, you can get by with just this. And don't forget, the advanced engineering book by Kreisig also has all that extra vector calculus. That's why this book is just gold, right? It's just like, honestly, if you're broke, okay, and you have to spend your money on one book, this one. And I say this one because, like, well, this one's pretty good too. This is this is one of my favorite books. A lot of these books are really good. I say this because Like, for example, this calculus book, you can probably get this cheap, or you can get a different calculus book. You don't have to get this one, right? Like, I used the one by Larson to teach in college for years. It's also a great book, right? The one by Thomas is also great. So there's a lot of good choices. But this one you can never find inexpensively. Like, it always costs, it's never like 20 bucks, right? It's always more. And it contains more information than any of these books. So I feel like you get the most value from this book here, Erwin Kreisig, Advanced Engineering Mathematics. Oh, I love this book. I love this book. It's like epic. It's epic. But yeah, just wanted to make this video. Subscribe, like, share if you want to. Physics is hard, right? Don't give up, right? Don't give up. And you know what? If you're a physics major, you're among the few, right? They're rare. Physics majors are super rare. So there's not that many people who do physics, just like math, right? Math majors are also a rare breed. It's one of those pure subjects that a lot of people, they don't go into, right? Most people go into things that have more opportunities for work. I mean, with physics, you can get a job, but a computer science degree or an engineering degree typically has more opportunities. Physics is more of a pure subject. So yeah, pretty hardcore, kind of like math. As always, take care, and I hope this video has been helpful to you. Later.